So this next session will be presented by Dominic Heutelbeck, and it's interesting because we've crossed paths previously, and he's working in all sorts of fields of academic research, if I can say so. And usually, out of the research comes a really nice paper, right? Nice as in, yeah, interesting. But what are there any tangible results? And I was really surprised that when we were invited to have a conversation about attribute-based access control, I was like, okay, here's another theoretical thing again. But I was really surprised in that conversation how practical, usable, and actually production-ready this stuff already is. And what was even more exciting, it integrates really nicely with Axon. So I am really curious to see. I kind of know a bit of that story, but I was pleasantly surprised. I'm pretty sure you will be too. So please give a warm welcome to Dominic Heutelbeck.
Thank you very much, Alad, for the kind introduction. So yes, and I'm so sorry. Alad promised me fun earlier, and I'm talking about access control with a thick German accent. I'm trying to make it as exciting as I can. So, who in the room has ever had to implement some sort of access control in their product? So, keep your hand up if you have done role-based access control. Keep your hand up if at some point there were some conditions that were no longer able to be expressed in roles only. And if you have done it in Axon, have you written an aggregate where in the header of your command handler you had a big block of code taking care of who may execute this command actually? Yeah, so this we're getting narrower and narrower. Okay, but there, yeah, exactly, that's happening. So, and the same may happen on the query side, right? So, yeah, who may see what, under which conditions, at which time, at which step in the process. And yeah, often the simple approaches supplied by Spring Boot or all the other frameworks fall short, and a lot of it ends up clogging up your main domain logic in some way or form. And then there is an approach that is not new. It's attribute-based access control, which promises you to, yeah, we can express all of that and solve all those problems with a nice new mechanism and model, and so on. There are several flavors of attribute-based access control. My talk will be in two parts. First half will be, okay, what the hell is that? And what kind of technology did we develop? And the second part will be, how do we apply that in the development of Axon applications? Okay. What is attribute-based access control and SAPL? So, attribute-based access control means we're just not using this model of permissions, which imply a certain set of things or roles that are assigned to permissions. We're not limiting ourselves to some specific access control model like Biba, Bella Padula, Clark Wilson, whatever you have in the academic literature, or what your specific needs are. No, we are saying there's some abstract way of describing what you're talking about. Somehow there's always someone in ABAC terminology that is the subject who is trying to do something which is an action with a resource. This may be your typical CRUD, create, read, update, delete operation, but it may also be, if you're talking domain-driven design, much more domain-specific. That may be something you would capture in a command, or it would be sending a query and reading data from a read model or projection in an Axon application. But in essence, we're always posing the question, this subject wants to perform this action with that resource. And maybe there's always this asterisk at the end, maybe in this environment with these side conditions. But for the most part, for the conversation, we drop that because it's required often, but it doesn't contribute and only complicates communication often. So we have the subject, and the subject has some attributes. For example, if we're in a medical domain, what's the job occupation? Is that a doctor? Is that a nurse? Is that some guy from the IT department? And now you may say, okay, isn't that a role? No, not necessarily. That's really just part of your domain model, and that's not the role. Because a role is something very specific from access control, which is assigned to a set of permissions, and we're not talking about that at all. It's just the occupation. And that subject may have a schedule. They may have a working schedule. If you want to do something like, yes, they may access the data, but only if it's their shift. Right? Then the schedule of the subject is something you want to take into consideration. Then you have a resource that wants to be accessed, to be done something with, and that also has attributes. Of course, for example, you have a machine you want to operate, and that machine has some requirements with regards to qualification of the operator. So it requires that you have the certificate to operate this machine, or that this machine or this sensor of the patient is assigned to a certain ward in the hospital. So, and then we have, of course, the actions. And that also has parameters, attributes, in which context, from which IP did it get sent, how often do I do this, what are the parameters, and so on. And in attribute-based access control, on the very high level, it's just, okay, we specify in some kind of way a mechanism that takes in these attributes of subject, action, resource, applies some rules that we present digitally. In our case, we have a domain-specific language for that. You may have heard about XACMO. That's the old stuff that we don't like, that we used, and we didn't like it so much that we decided to do something else and better. And yeah, these rules then are evaluated in light of these attributes, and you get out a decision. Overall, you have this access control mechanism, and in your code path, you have something called a policy enforcement point. Basically, the code path where the developer says, yeah, here is something to protect. Here we have to do some access control. That's the policy enforcement point, because here you have to enforce whatever decisions the mechanism implemented in the policy decision point makes, which is the point where all these policies and rules are stored, gets in this authorization question, and it spits out an answer. So that's the very high-level idea, what's attribute-based access control. Good. So if you look a little bit more deeply in the functional architecture behind this, like I said, you have the policy enforcement point where you would be in your code, that's your command handler in the Axon application or your query handler. And then you have behind that the logic exposed through that handler, which is the resource access point, or which would be the query to the database behind your projection, handling the query. And the policy enforcement point asks the policy decision point, is it okay for this subject to do this action with this resource? And in our case, we're not doing, you may have spotted it if you look closely, we're not doing request response, because that would be awkward also in this world of event-driven and everything is updated. No, we're doing also a publish-subscribe scheme here in our technology, in the SAPL, Streaming Attribute Policy Language, more about that later. So we're subscribing to this. And basically, we are keeping the PEP updated about any changes that occur, because changes can occur at runtime, because on the one hand, the policies may change. Somebody says, okay, no longer does that doctor have access to it. We put him on a blacklist. right? So that should be reflected at runtime. And the policies may refer to outside information that is dynamic. Be it, for example, an attribute of the subject to which team and which function they are assigned to, which may change at runtime, which is very interesting in highly dynamic collaborative applications. Or, for example, time changes or the status of a machine changes because it's now in maintenance mode. Now you may access it. But as long as the machine is not in maintenance mode, which is somehow an event sent over whatever, over MQTT to your to a broker, and the PDP can subscribe to that and at runtime can adjust without updating what kind of decision that is. This is the difference to traditional ABAC architectures, is that we are doing all of this in a publish-subscribe way. So why would I do this? Okay, on the one hand, it's really, I can be very domain specific in my expression there. If you, another rise of hands. I know most of you did the ABAC thing. Have you ever seen role explosion? Do you know what that is? When you have not one system that has role-based access control, but several, and then in your directory, you have to introduce more and more roles to somehow express all the permutations of permissions that people may have. And in the extreme case, you end up with more roles in your directory than you have users. So, which is for me always, it's misusing an access control mechanism. So if you run into this, I think maybe that was not the right architectural decision to choose that access control mechanism, even though it is very convenient and easily supported by all frameworks. Right? So yeah, so if you want to express something more specific, you can do that. It's a superset of all kinds of models. You can be very domain specific. You can do the nice secret service, top secret, Bella Padula thing. You can do Biber for integrity checking instead of secrecy and confidentiality. So it basically includes all of that. So, and then you have this nice thing. You can write down your policies separate from your main domain logic. You have a certain separation of concerns, which really helps to keep your aggregates clean, for example. Like I said, you write this block. I did that at least with a customer, where I had to write some specific logic for every command handler to check, okay, which relation does that user have to this object, and in which state is it? Is this task assigned to that guy or not? Only that one assigned to that may change this, and you have this kind of logic there. But it's really something orthogonal to the actual process you're trying to build in the aggregate, and that may be subject to change. So also by making this kind of separation, you're just improving the testability of your aggregates because you're keeping them more simple. You can concentrate on that. And you can separate the testing of the access control as well. So both is testable with their own basically set of unit tests. So then it's dynamic. They can change at runtime, which may be important, which also means that you have a decoupling of processes in your teams. You have different teams working on the code and on the access control potentially, and you do not need to couple the release cycles when updating the access control policies as compared to you've done Spring Boot, you have annotated your role-based access control annotations, and that's in your code, and you change that, and you have to do all the, okay, if you're doing continuous delivery, that's of course super efficient, but still you have to go into the loop of development to do so. So this has, like I said, separation of concern on code base, but also organizational. And of course, there are cons. This is a much more complex model to adopt in the beginning. Course, it's computationally more complex depending on the way you deploy it. It may include an additional service call, which may include matching latencies with a quick asterisk there, which with going with the publish subscribe thing, you have the advantage that only the first one will have the latency and the updates are pushed. So as you're avoiding polling, you're not using up the resources and optimizing on latency of updates when conditions change, because this is just event-based as well. And it is not provably correct. It's not easy to prove something formally about these kinds of models. There are other models that try to do that, like NGAC, but that these provable models are either on the not that expressive end, or at the, if you write something there, you will see that's very close to papers in theoretical computer science with matching directed acyclic graphs and some kinds of rules, and it's difficult to communicate with the stakeholders. So you have to find the balance. How provable do I want it? Okay, but it does not, and that's important, it does not impact testability of your policies. And we come back to that later. So overall, you're in a situation to decide if you want to do ABAC, if all your requirements here that the organization has, you express them as requirements in so-called natural language policies. You have business requirements, development, operational requirements, and then you have to select the mechanism and the policies, and just the important part is, come on, this must match up with your needs, right? So, and with this kind of mechanism we're introducing, we're providing you with an additional tool in your toolbox to be able to tackle these kind of challenges if you encounter them. So, what's SAPL? SAPL is our engine. Like I said, in some project I had to use other ABAC tools. They had the disadvantage that in the expressiveness, I'm not going into details, we were not so capable to express the kinds of policies we wanted to do. The tooling is terrible. The syntax of the policy language is terrible. For something in SAPL, which takes 2 lines, would be 2 pages of XML code in the other one. So something like that. So we are offering our own policy language and policy engine for that. We have an embedded policy decision point. We have a policy decision point server. We have integrations with different frameworks, Spring Boot, Vaadin, Axon, with Python, with Django and Flask. And we have streaming pips, these external data that can be used for decision making. These are the pips. And we have extensions for using MQTT for doing geofencing. That means, for example, if one of your subject attributes is the location of someone, you can access a geodatabase, and we have functions to check if a point is in a polygon on a map. And you can dynamically update those from the geo-information systems. We have integrations with Ethereum to say, okay, if that guy owns that NFT, that expensive monkey, then he has the additional rights. No, we're not doing these nice monkeys. We're doing, for example, educational certificates, which was the example with the machine operator. So in the blockchain, after you completed the Axon certification, you are, of course, able then to authenticate and use the Axon server, because you have in the blockchain that certificate without going to HR first and showing them a photocopy of your big certificate. It's extensible, it's open source, Apache 2.0. We have a homepage, sapl.io. We have a SAPL extension and a full stack, not full stack, it's with a REST endpoint, not with an UI, but a complete Axon demo as well. So what does that look like? It's basically on the data model, it's JSON-based. You pose your authorization questions in the form of subject action resource, which are JSON values, send that to the PDP. The PDP looks at all the rules and policies and comes back with a decision here, which may say permit or deny, or it may say permit but. So it supports something called, we call them constraints, which may be mandatory or optional things you have to do while granting access or while denying access. I will have a few examples of that when we look at the Axon example for that. And we can do multiple subscriptions that we do not have to do all kinds of connections at the same time. You can bundle all these questions as a subscription with multiple topics basically, and you get back a stream of updates on the decisions for all the questions you have in the multi-subscription. So this is what a policy looks like. And I would say even, I'll keep that here on the screen for a moment, without you ever seeing any spec of the language, I guarantee you that you will basically understand what this says, because this reads like most of your high languages you are used to use. Right? So for example, here it's a policy that has a name, and if this evaluates positively, then we want to permit the action, and we're looking at the action where the command is hospitalized patient, and we allow the permit where the subject is a system process, for example, not a user, but we have some system processes running, or it is a doctor who is, here we have an attribute of the subject and of the action. The action is hospitalized to a ward in the hospital. So we may have a doctor, and at the same time, the target where the patient is to be hospitalized is a ward at the hospital, and this should be the same as the assigned ward of the doctor. So the doctor may only put patients in the part of the hospital where he is responsible for, or she, right? Very, very reasonable. And then we have these kinds of angle bracket notation, which, yeah, a very simple thing. You could have any external data stream connected, which is an external data stream. Anything in the angle bracket is a data stream. So we're looking here at time now, and this is, of course, not a realistic policy. Nobody wants every 20 seconds their access to something changed. It's just for demo purposes in the code that you see that something happens and you don't have to wait a few hours. So basically, the first 40 seconds of the minute, you have a permit, else you get something else, right? And this is dynamically updated. This is a polling thing, but we have also time libraries, for example, where you can say, as soon as we reach that time, that you don't have updates every second and you poll the clock, and this is evaluated all the time. This is very simple and dumb. We have a little more sophisticated stuff for that as well. So, okay, then we have, if you want to try out the policy language, you can visit our playground, where we have a code editor. You can have the authorization subscription here, and you will get an output of your policies, test it. Here you can then, it's not connected to real external data sources. You have to define them here as mocks, for example. Yeah, and you can experiment with that. The editor is also here available in the small version of the PDP server, where you have an administration UI. The code editor supports things like auto-completion of code and so on. You can select which kind of policies are active and not. Currently under development, we have an integrated development environment for policies, which will boot up in Gitpod with an integrated Visual Studio Code editor and a testing suite integrated. Then we have libraries for testing of your policies. So you can basically write tests. We treat policies like code. So basically you write your tests for your policies just like you would write any reactor or Axon test based on these kind of event abstractions. The test fixture will then tell you what the policy hit ratio is, what the code coverage is, and will generate HTML code coverage reports for your policy tests. So this is a pretty complete tooling, and we don't have time for that now, but this is really impacting of how you're integrating this policy engineering in your DevOps process, because this enables you really to treat it like code, have different teams work it, define quality gates, integrate it in your CI pipeline, and push it to production the way you want, either with PDP servers, with embedded PDPs that have local storage, and so on. Basically, this enables you to do anything of that kind of architecture for your CI, and it will not get in your way. So then we have the framework integration. So far you have seen the policy language and the theory, how is it used. I'm not going to go into depth with Spring Boot and Django and so on, but in essence it's a declarative thing, just like you would annotate a command or event handler, or in Spring Boot you would have something like pre or post authorize. We have pre and post enforce, which automatically deploys, Spring Boot, Spring Security, aspect-oriented programming. A proxy for this class where a policy enforcement point is automatically wrapping each of the methods, or even on class level if you like to do so automatically. And the developer really does not have to do more than do this annotation and he's done. But you can also do post enforce, where you use the return value, for example, of a method as the resource in the authorization question, because you don't know that in advance before calling the query model. And you can customize that, but that I will show later with Axon in practice. We have the same stuff for Python and all kinds of other libraries. Okay. I promise I will show more code. How to do that with Axon. So first, of course, we have to consider where does that happen. We have this, you all know this picture here, the Axon architecture. Where are the policy enforcement points? Of course, they are primarily here at the command handling, the result sending, and the query and result sending. And if you look at this picture, I found this a little bit limiting. I think it's more useful to go to the hexagonal architecture point of viewing things. So you would have the domain model in the middle. You would have your different query models, the event store, the different adapters with persistence. You have interfaces, which may be a UI, an API of some sort. And where would you want to deploy policy enforcement points? And that's, of course, if we want to protect state change, we're talking about commands. So we want to protect access to command handlers, because some subject sends a command, an action to the domain, and we want to make sure that gets protected. Then we have the query side. Who may see what? On the one hand, we had who may do what and make changes. And here we have, okay, I want to see the state, under which conditions. And we're also talking about subscription queries and so on. And of course, you may want to take care of your UI as well, because if you know that the subject is not allowed to hospitalize the patient, it would be really annoying for the user to have the nice button, hospitalize the patient in the UI, press it, and then have, oh, no, you may not. It would be much more beneficial if you are able to deduce so, to automatically also adopt the AI and make that button gray, or don't even show it at all if the subject is not allowed to do so. And for that kind of stuff, we have a deep integration into Vardin, where you can customize all the different components, attach policy enforcement points, and even have dynamically updating validators for forms based on policies. But we're talking right now about this area here on the command side and on the query side, and that's what I'm going to show you right now, how that would happen in practice with the SAPL libraries. Okay, good. So it was buffering. So it's really that easy. You have your command handler method, and here it doesn't matter if that's some domain service or if it's an aggregate, right? You can have both in Axon, and you use that and you add the pre-handle and force annotation. And then in the annotation, I said, you can customize what the authorization question would be. You can omit this, then the framework will do a best guess. What would be a reasonable authorization question, a subscription, would use the Spring Boot principle that's in the security context and marshal this to JSON, would take the command and marshal that, and so on fully. So you would end up with something directly usable, but pretty big and maybe too technical. Of course, we can only reason about technical things in the framework. And if you want to do some reasonably readable policies that are close to your domain as well and that are able to be communicated to your stakeholders, then you should customize it and take care of that you have the right information here. So you can use Spring expression language here to customize the authorization question. So here again, there is this wrapper around the command handler that then constructs this authorization question according to what we have here. Like you see here, we didn't modify the subject, so just the Spring Boot principle got marshaled to JSON, and we have these nice representations of our action, which was a hospitalized patient to the general ward, and this was all about some patient, we don't know yet which one, because that would be data regarding to the aggregate, but later something about that as well. So, and yes, no, this is actually information about the patient, because this is an example where the command handler is in the aggregate. And if you look here, you have var colon var, which means here I can actually access aggregate state. Because this is in the aggregate, this is done after replay and before invocation of the command. So we have an aggregate which is already at the right state. We can access different attributes of the aggregate, which is fine because this is in the command processing stage. So we may look at the stage to make decisions. We're not in the simply event replay stage. And so we can use this to formulate our authorization question, and then it comes back, and in this unit of work, it's allowed or not. Okay. So then we have the matching policy, which is evaluated. We have seen that before in the example. You get a deny in this case, and yeah, in this case, the command handler throws the access denied exception, and the command handling fails. Pretty straightforward, but of course it's the cycle. This is the overhead to generate by using this kind of model, but this is also the flexibility you gain. And the clicker. Okay, so sometimes permit and deny is not enough, right? You want to say, yeah, permit that action, but, for example, modify the command. So if they wanted to withdraw 20,000 euro, no, those people limited to 10,000, replace it with 10,000, for example. You can add runtime before executing the command handler, change the command. Maybe it's on the command handling side, trigger additional commands you want to send. Yeah, grant access, but also trigger this audit process, and therefore send to the auditing service this command to start that. Log it somewhere, or emit an additional event. because, yeah, somebody else that's suspicious access this aggregate in that way, log this as an event that we can later take care about that. That's also important for the infamous breaking the glass scenario. So the doctor, in emergency, you may access data of all patients because you don't want them to die. But if somebody does that in the context of emergency, you want to audit that later to make sure that was not a misuse of this capability of accessing the data. You can model these kinds of processes there. Or you have a query or aggregate and you want to modify the result. Yes, they may see the medical data, but only give them the first high-level category of the medical classification and not the details. And in deny, trigger it also. You don't, only deny it and nothing is logged, but for some things that are denied, you want the documentation that access has occurred. And these are all kinds of constraints, and they are either must or should. Must is an obligation, should is an advice. Let's stick mentally to obligation. You must do this, and if you're not able to do this, then also do not permit access. Right? So here we have an example again with this patient data from the demo project I showed you the link to. And so we have this command handler. It's again pre-enforce. That's the same as before. It doesn't matter here what the payload of the question is. And we have a policy which evaluates also the details here above are not important. The important part is this gives a permit and it adds an obligation to the decision, which says document suspicious manipulation of this username. So this is, okay, somebody from a different ward connected or played with the health monitor of that patient, do something about that. So here you can see we have an additional method in the aggregate, which is annotated with constraint handler, which says, okay, if the constraint is of this nature, this is again a Spring expression language expression, then this should be executed, and this then consumes the obligation, and this is executed before the command handler is executed. And if this fails, the entire operation fails, right? So we have other ways of doing that. You can deploy global constraint handlers, which are just beans that expose it, that are asked, are you responsible for this kind of constraint? And then they get hooked into this kind of handling. Okay, so you can do everything you can do in a command handler in a constraint handler here. So you can create other aggregates, apply to this aggregate a new event. And this will show up in the matching event stream of this aggregate then. And it's just as if you would have coded here manually, okay, if the metadata subject punct so-and-so matches this and that, then throw access deny, else apply this command with a disadvantage that the application logic gets clogged up. You don't see anymore what you're doing in essence, and it's not changeable at runtime. Okay, these two match, so it's handled. Then we have query handlers. For example, we have here the annotation post handle enforce, which means this policy enforcement point is invoked after the query handling method here is triggered. So we have, in the context for constructing the authorization question, we have the query result available. And we can put the query result into the authorization question. Again, the matching thing is created. And if you see here, for resource, we see type is patient, and the value as defined here is actually serialization into JSON of the matching object that's returned here, which would be the patient document because in demo it's all stored in a MongoDB. So we have the matching policy here, and this policy has another nice feature. We have a special case of obligation that is in the policy language, which says transform. Please transform the result, and then we have some nice filtering and templating syntax to basically construct arbitrary JSON objects again. And here we have a subtractive filtering expression. I'm not going to be very detailed here, which just says we here have a JSON path expression, and everything that matches this JSON path apply this function to, and this is the blacken function with remove, which blackens everything but the first two characters in this example. And you can do blackening, removing, replacing. You can replace it with an arbitrary different object and so on. Right? This makes sense because we have it, and this makes only sense for query response. It doesn't make a lot of sense for subscription queries. So there we have different methodology. Okay, and then the decision includes this resource, and because it also had it has had another obligation also inside, what happens is the result of the method is replaced with an optional of this object where the string is blackened, and also some public bean, global bean was triggered that emitted a domain event in the form of, here it was a message of to log it, log access event. This is an access attempt event. That's not an aggregate event, but a global domain event that's not assigned to just any aggregate, and this kind of thing can also be logged and triggered here, of course. Okay, so subscription queries, and we are slowly closing in on the more sophisticated things here. So this is really where SAPL and Axon really match up well, not only because they're both event-driven, but they also both have this idea of we are not only looking at query response. We're looking at long-standing monitoring of state change. We may look at something like IoT data, analytics data that is updating in real time, and so on. And this is really where this event-driven authorization really shines. Because if you only do authorization at the beginning of your subscription, and this is a long-standing subscription, and at some time during that subscription, your rights are get taken away. You're monitoring a customer's IoT stream for maintenance of some machine, and your contract gets canceled. But this is a machine where the connection stands for weeks. They will still be able to access it because you only have the policy enforcement point at the time where you subscribe to the data stream. Basically, we are looking at putting that both together and monitoring it and adopting the policy enforcement runtime. We have three modes. I have to speed up. We have just enforce it before accessing it, and as soon as the first deny comes, cut off the subscription query. We have drop updates while denied, means, yeah, okay, stay subscribed, but as long as the access is denied, don't propagate any events, which has the drawback that the client will not know if they have access or not. If you need to know that you have access or not, you can use enforce recoverable updates if denied, which also communicates access denied events, but is able to recover from that and stay subscribed, which required some quite deep hacking of the Axon update emitter and so on. Okay, so again, it's really straightforward. It's just the same as before. You have on the initial query handler, you have the enforce recoverable if denied, or any other flavor you want on it. And here, if you want to recover, you can make use of this a wall of code. I know I'm not going into depth, but you can use something like on error continue and callbacks for access denied to stay subscribed to that query. So you have this really nice thing, and you can do, there are constraint handlers that are wired in the entire life cycle of this subscription query. So for example, we have default constraint handlers where you can define a constraint that says, okay, on a certain condition of the object, do this kind of filtering with the object. So that means every time an update is emitted, there is a transformation potentially applied. You can say that because it doesn't make sense for each update to ask the PDP again. That traffic is horrific, sending all the payload back to the PDP. No, you want to inform the PDP about some rules to apply. And this is all the kind of stuff you can do dynamically. And it turned out that this works really well with this approach. Here we have this time-based thing where every 20 seconds access levels change to the patient data. We have exposed this as server-sent events in Spring Boot, and it's backed by the matching subscription query. And you will see that here we, for example, have a handler where we have the raw data, and sometimes the policy says, okay, only give the category of the blood pressure. Is that normal or is it high? But don't give the thing. So you can in flight transform the data, and in between not show the data, but while this is not shown, you are able to react on these access denied events. This is really nice if you build a UI where you have something that can say, okay, currently you do not have access, and suddenly we have a push. Vaadin, for example, you can update the UI and you automatically get that data shown to the end user if the conditions are met. So, okay. And the clicker is wonderful. So, yeah, I hope I was able to be at least a little bit exciting here in the front with regards to access control and show you what is possible beyond the traditional ABAC and so on. Show you that we have this thing available. We are planning to do a full release in the next weeks. We were waiting for the updates to 4.6 because there are these publishing reactor-based query return types. We will do the matching adjustments to be able to handle that and release it. Currently, it's in a snapshot release. It's in the public central snapshot repository available. And you're welcome to use it, to contribute, to talk with us. We're providing open source community for that. We're trying to build that up. And if you want to adopt that in your product and need consulting with that, we are there, of course, as well. So that's it. Thank you.
We have questions in the app, but do we have time? Oh, we have time. Oh, fantastic. And there's actually votes on the questions too. So there's a question that came in quite early already when you were talking about the testability and it being one of the downsides of this is that it's difficult to test. It says, if this method is not or hard to prove, how do you deal with audits?
Okay. Yes. So there's two types of audits. Especially what kind of audit we're talking about, right? So on the one hand, I think you have to establish a process where you have if you're in a situation where audits are actually a problem and a challenge, then your development process also includes the matching requirements, documentation, and the natural language policies. And your tests, like I said, we have this testing framework for policies, should map to that requirements document and systematically go through that. So you can, of course, not formally prove that these policies do what they should. That's a whole other can of worms. But you deal with it with like any other audit question regarding code. Does your code comply? Here is the documentation, here's the code, and here are the tests and what we did to establish to ensure that. It's just like any other piece of code. And then you have the other part of audits is, did that work at runtime? And there, of course, you have these kinds of obligations. If you have to audit this, then you can establish these kinds of obligations that publish the matching events that are able to to enable this kind of audit post-mortem. Also, we're working on some features to improve observability at the server level. So if you're deploying then the PDP server, we're right in the process of turning it also into a product that this has the matching features to have observability.
Excellent. So another question that is upvoted a few times. How do you react to model change? Do you update the paths of your policies automatically when your command/aggregate/query changes as well?
No, there's no automatic process established for that. So SAPL by itself is completely neutral to the framework. As you have seen, it's for generic Spring Data, annotate your Spring Data repository or annotate your reactor flux for streaming authorization, but there is no direct model coupling established at this point in time. Maybe that can be done for a project where that is needed, but there's nothing out of the box.
Our term keeper ran off, so I just assume we have more time. Right? No news is good news. Is there anything you can say about the performance overhead of SAPL with Axon?
Mm-hmm. It currently really depends how you want to deploy it. So you can either link the policy decision point to your Java code, have it embedded, and even if you have microservices, you can ship the policies with that, and I've shown you this continuous integration setup. So you could deliver updated policies to those microservices as well. And then you have, of course, the things are local with a service. They are cached in RAM. And we have also published papers about that, a sophisticated policy indexing. And then you can have several thousand authorization steps for microservice ready. If you introduce remote service for that, you just introduce the lag you would have anyhow, and depending on your authentication and authorization needs. Right? If you deploy it behind basic authentication, it will be very slow. If you deploy it behind some access tokens, it will be fast. Right? And it's mostly, I consider it a matter of the network delay. And it's not generally answerable because I cannot know how many policies you will have, how complex your rules will be, and how many additional external calls to additional data sources you make. All that impact performance, and SAPL doesn't care. It supports all of that, and we're working on some additional caching algorithms locally and remotely and so on. But there's not possible to say in general. But if you have simple policies, it's several thousand authorization, 20,000 per second, no problem. And then the delay depends on how you deploy it, and if you put a network between or not, and what the nature of that.
Leaving the door wide open is always faster, but might not be the best option, right? All right, I think that's about all the time we have. So there's one thing I want to say, because I know how deep into the Axon framework you need to go to get some of this done by just putting an annotation on it. And for us, that's kind of doable because we've built the thing and we are blamable for all of the code. But Dominic did it all from the outside, let's say. So he was looking at somebody else's code. Just imagine looking at your own code and already thinking like, wow. He was looking at somebody else's code and got that working pretty neatly. And I think that that deserves a big round of applause. So, thanks a lot.